Why are there not more people talking about the incredible journey of Apollo 16? This mission was not just another step in lunar exploration, it was a giant leap in our understanding of the Moon and our place in the universe. Join us as we dive deep into the Apollo 16 mission and uncover the groundbreaking discoveries that continue to shape our knowledge of space today. Scientific sleuthing experiments on the Moon's surface. The Apollo 16 mission was not just about collecting rocks. The astronauts conducted a variety of scientific experiments. One of the most important was the Passive Seismic Experiment. By studying moonquakes, scientists hoped to learn more about the Moon's internal structure. Another key experiment was the heat flow experiment. The astronauts drilled holes into the lunar surface to insert probes. They also deployed a cosmic ray detector and a solar wind spectrometer. Section 1. The Apollo 16 Subsatellite, a silent sentinel in lunar orbit. While John Young and Charles Duke explored the lunar surface, a silent sentinel embarked on its own mission. This was the Apollo 16 Subsatellite. The Subsatellite carried a suite of instruments designed to study the Moon. It was a miniature space observatory, its mission to orbit the Moon and collect data. The Subsatellite was a marvel of miniaturization. With a gentle push, the Subsatellite was released into lunar orbit. Unveiling the Subsatellite's payload. The Apollo 16 Subsatellite carried a powerful array of scientific instruments. Each instrument addressed specific scientific objectives, from mapping the Moon's magnetic field to studying its atmosphere. The data collected provided new insights into the Moon's history and evolution. Key instruments included a magnetometer to measure the Moon's magnetic field. The Moon's magnetic field is weak and patchy, unlike Earth's. The magnetometer mapped these anomalies, revealing the Moon's internal structure. The particle shadow detector studied the Moon's interaction with the solar wind. The solar wind bombards the lunar surface with little protection from the Moon's weak magnetic field. This instrument measured solar wind particles, providing insights into space weathering. The Subsatellite also carried a mass spectrometer to study the lunar atmosphere. The mass spectrometer identified gases in the lunar exosphere, revealing their origins. The Apollo 16 Subsatellite's mission aimed to answer fundamental questions about the Moon. How did it form? What is its internal structure? Does it have a molten core? The Subsatellite, with its suite of scientific instruments, was tasked with unraveling these mysteries. One primary objective was to map the Moon's gravity field. It also studied the Moon's interaction with the solar wind. Another key objective was to search for evidence of a lunar ionosphere. The Apollo 16 Subsatellite, like a faithful messenger, diligently relayed its precious data back to Earth for several months. Its instruments, operating flawlessly in the harsh lunar environment, provided a treasure trove of information that kept scientists busy for years to come. This data, combined with the samples and observations collected by the astronauts on the surface, revolutionized our understanding of the Moon. The Subsatellite's magnetometer data revealed a surprisingly complex magnetic field, with pockets of magnetism scattered across the lunar surface. These magnetic anomalies, scientists believed, were remnants of an ancient global magnetic field that existed billions of years ago when the Moon's core was still partially molten. The particle detectors provided valuable information about the solar wind's interaction with the Moon, confirming that the lunar surface is constantly bombarded by high-energy particles. This data helped scientists understand the processes that create the lunar regolith, the fine, powdery layer of dust and rock fragments that covers the Moon's surface. And while the Subsatellite did not find conclusive evidence of a permanent lunar ionosphere, its instruments did detect brief periods of increased ionization in the lunar exosphere, suggesting that a transient ionosphere might form under certain conditions. This discovery opened up new avenues of research into the complex interactions between the Moon, the solar wind, and the interplanetary magnetic field. The Apollo 16 subsatellite, a silent sentinel circling the moon, provided a completely new perspective on our celestial companion. Free from the constraints of a surface mission, it orbited the moon tirelessly, its instruments diligently recording data that would reshape our understanding of its history, its environment, and its place in the cosmos. One of the most intriguing discoveries was the confirmation of widespread magnetism on the lunar surface. While scientists had suspected the presence of magnetic anomalies from previous missions, the subsatellite's magnetometer provided the first comprehensive map of these enigmatic regions. It was like looking at the moon through a new lens, revealing hidden patterns and structures invisible to the naked eye. These magnetic anomalies scattered across the lunar highlands presented a tantalizing puzzle. How did they form? What did they reveal about the moon's ancient past? The prevailing theory was that these magnetic regions were remnants of a global magnetic field that once enveloped the moon billions of years ago, generated by a molten core that has long since cooled and solidified. The subsatellite's observations provided crucial evidence in support of this theory, suggesting that the moon, despite its current appearance as a cold, inert body, once possessed a dynamic interior capable of generating a magnetic field similar to Earth's, though weaker and perhaps short-lived. This discovery opened up new avenues of research into the thermal evolution of the moon and the processes that shaped its early history. Section 2. A Lunar Mystery, the Case of the Missing Volcanoes. Apollo 16 aimed to find volcanic activity in the lunar highlands. Surprisingly, they found few volcanic rocks. Instruments found no evidence of active or ancient volcanism. If not volcanoes, what shaped the highlands? Scientists realized impact craters sculpted the terrain. Craters pulverized the crust, creating the rugged landscape. Section 3. Echoes of Apollo the subsatellite's impact on lunar science. The Apollo 16 subsatellite mission played a crucial role in advancing our understanding of the moon. Its data provided a unique perspective, revealing secrets that would have remained hidden from the ground. Observations of the lunar magnetic field and solar wind interactions offered valuable insights. The subsatellite's legacy extends beyond its discoveries, ushering in a new era of lunar exploration. Robotic missions have built upon the Apollo program, mapping the moon and probing its interior. The Apollo 16 subsatellite paved the way for these missions, unlocking the moon's mysteries. Section 1. Apollo 16, a legacy of discovery. The Apollo 16 mission, a testament to human ingenuity and our insatiable thirst for knowledge, left an indelible mark on the annals of space exploration. John Young, Charles Duke and Ken Mattingly, the intrepid explorers who ventured into the lunar unknown, returned to Earth with a treasure trove of scientific data and a renewed sense of wonder about our place in the cosmos. They had explored the rugged lunar highlands, driven the moon buggy across cratered plains, and conducted experiments that revolutionized our understanding of the moon's history, composition, and interaction with space. Their discoveries challenged long-held theories, sparked new debates, and inspired generations of scientists to continue unraveling the secrets of our celestial companion. But the legacy of Apollo 16 extends beyond its scientific achievements. It reminded us of the power of human collaboration, the unwavering spirit of exploration, and the importance of pushing the boundaries of what's possible. In a time of global uncertainty, the Apollo program, with its message of unity and ambition, captured the world's imagination and offered a glimpse of a brighter future. The grainy images of astronauts bouncing across the lunar surface, the iconic photographs of the Earth rising above the lunar horizon, these became symbols of human achievement, etched into our collective memory. Apollo 16, a pivotal chapter in this extraordinary saga, reminded us that we are capable of achieving great things when we dare to dream big and work together towards a common goal. The moon beckons, a new era of exploration. The Apollo missions may have ended, but our fascination with the moon has never waned. Robotic explorers have continued to probe its mysteries, mapping in greater detail and touching down once again. These missions have revealed a moon far more complex and dynamic than imagined. We've discovered water ice and hints of volcanic activity. Today, a new era of lunar exploration is dawning. Space agencies and private companies are setting their sights on the moon. The Artemis program aims to land the first woman and the next man on the moon. The moon, once distant, is now within our reach. It beckons us to return and unlock its potential. The legacy of Apollo continues to inspire us to reach for the stars.